Here we go.
Cool. It's live. All right. So for this Share Friday, we're going to go delve into kind of the modern front-end frameworks in a web development environment. And it's by no means exhaustive, but I'd like to cover kind of some of the popular different JavaScript flavors and the frameworks that are quite popular. So first off, every single website on the internet is made with HTML, CSS, and JavaScript. That is the entirety of the internet. It's HTML, CSS, and JavaScript. Every single website has that. HTML being a markup language, CSS being a styling framework that's infamously hated, and JavaScript being kind of a programming language usually used for animation and stuff. To note, there was kind of Flash before, so you used to have some Flash games, but I think that's slowly becoming deprecated. And I'm just going to share my screen now. So what I'm going to do is I'm going to delve into the different kind of frameworks. So, well, first I'm going to delve into the different languages. So at the end of the day, every single website is built in with JavaScript as its kind of language on the front end, and you have different people. A lot of people don't like JavaScript, and for the common reasons of it being loosely typed as well as being non-functional, object-oriented. So there's a series of different languages which I'm going to dive into now, from the least well-known to the most well-known kind of variants of JavaScript. Yeah.
Dan, I'm sorry to interrupt, but before you quickly start on that, do you know why was it chosen that JavaScript is going to be the language that the internet runs on?
Language of the internet? It's a very good question that I don't know the answer to.
I know. Can I answer?
Hit me up. Go for it, yeah.
Yeah, I mean, I don't know the full story, right? But I read a few articles on this, and it's basically like because of Microsoft, right? There was this guy back in the 90s who wrote JavaScript, and he wrote it in 10 days. And Microsoft's Internet Explorer was like this amazing takeover. It did this amazing takeover for the whole web and like brought the web to the people. You know, before then the most popular browser was okay and it was great, but it was only really used by people who properly understood computers. And then Internet Explorer basically brought it to the man, right? And that stuff was written and pushed by Microsoft, who did JavaScript stuff. And from then on, all other browsers had to be like backwards compatible. All websites had to be backwards compatible with Internet Explorer until Chrome came along, took over. But Chrome and Firefox, but that took a long time. So basically, you had all this stuff build up over that time, and now it's just a backwards compatibility nightmare. And that is why JavaScript is the ruling power, like in a nutshell.
I have a few more things to add, which I think are interesting. Firstly, the original design of JavaScript before it was called JavaScript was very much like Lisp-like, so the language with lots of curly brackets everywhere. And I'm not sure who gave the instructions, but basically at the time Java was the main sort of language that was up and coming and everyone was raving about. And they were like, no, it needs to look like Java, and that even influenced the name. I mean, JavaScript has really nothing to do with Java besides it using like curly brackets and a few things where the functionality is the same. What's his name? Brendan Eich is the guy who actually invented it, and he's gone on to do some pretty cool stuff. He founded Firefox after that, and he also is now in charge of the Brave browser. So, yeah, some history.
Okay. Great. Yeah, thanks for answering that. So to give you just an overarching kind of table of contents on what I'm going to go through. So I'm first going to talk about some of the different languages that people like to program in, which is what you're seeing on the screen now. Then I'm going to discuss some of the frameworks, and those will be like Angular and React. And then I'm going to talk about some of the server-side languages frameworks, just mentioning them briefly. And then it's just some kind of honorable mentions on some other notable like JavaScript front-end frameworks that solve certain problems. So essentially, people don't like JavaScript. So there's a series of other languages that you can use to program in the web, but essentially they're all kind of compiled to JavaScript because that's the language that's supported by browsers essentially. So as you can see here, we've got PureScript. So I'm going through for them from least well-known to most well-known. And that's not by, so it's not the least popular, it's just the least well-known. So PureScript is a fully typed functional programming languages. So you'll find that quite a few of these are functional, being a shortcoming of JavaScript. And that compiles to JavaScript, and it's kind of based on the Haskell syntax. And this is that here. You can check it out. Some of the more strengths and weaknesses, etc. Then Jason's absolute favorite, Reason ML, which is similar, based on top of OCaml. The syntax is similar to, it's like, I'd say the syntax is a cross between JavaScript and OCaml. Jason, correct me if I'm wrong, and I'll ask you to add some points to it now. But essentially, in the web environment, it compiles to Script, and it's also a typed language, typed functional language, developed by the founder of React, or the initial developer of React. And it's also developed by this singular guy, and his name's not on this site. And I've got Script here for reference as well. But Jason, since this is your forte, I thought maybe you had something to add to it.
Yeah, sure. So OCaml is a reasonably old language. I think it's younger than, yeah, I'm not too sure. It's very, very similar age to Haskell, but I think Haskell's older than OCaml. OCaml kind of took a slightly more middle road, where Haskell is quite extreme. Haskell is pure, and you actually can't do anything unpure. So pureness on a language is your ability to mutate values and things like that. OCaml is pure by default, but if you really want to mutate something, you can add a like a little tag on that variable to allow you to mutate it. So it basically forces you to code well unless you really, really have to mutate something, which is quite nice in my opinion. And the name OCaml actually, it comes from a family of languages called the ML languages. It has nothing to do with machine learning. I think the ML languages came out very, very academic sort of family of languages, like in the 70s, by like maths professors and those sort of people. And it's a very sort of distinct sort of type system. And OCaml actually, the O is like sort of objective. So they kind of were taking some influence from object-oriented programming, although you would hardly call OCaml object-oriented, but there are some concepts from there. So it's less of a purist functional programming language than Haskell. As for Reason, I've only been speaking about OCaml. Reason is actually purely just a new syntax. So the syntax of OCaml looks very much like Haskell. If you want to go back to the PureScript tab, I think there was some code, Denim. Mm-hmm. Yeah, you can see there's no curly brackets. When you sort of apply arguments to a function, you don't put commas between the arguments and things like that. Whereas in Reason, it actually looks very similar to JavaScript, and that's intentional. The designer of the language firstly loved OCaml when he wrote React. Apparently, a lot of his design decisions came from his experiences with OCaml. But he realized very few people would quickly be able to learn OCaml because the syntax is completely different. So that's really what Reason is. And then the next tab, the project called Bucklescript. This is the...
here we go. That's where you can see the difference between the two syntax.
There we go. Yeah. So Bucklescript is the pure script for OCaml, basically. So very similar project that allows you to take OCaml code and turn it into JavaScript. The design goals of Bucklescript are to be really fast and to be very as easy as possible to interop with JavaScript. So some of the difficulties that must sort of be highlighted is JavaScript is extremely dynamic. So a JavaScript object can have, it can be like a dictionary. So you can have keys and values. Then those values can be arrays, and in those arrays can be anything, which typically isn't allowed in sort of irregular shapes aren't allowed in functional languages. So those are some of the challenges, but Bucklescript is very well designed to account for that. I guess there's more I can say, but let's give it back to Denim.
Yeah, let's try get through this section. I know Sean has to leave a bit early, so I'm going to continue through these languages. Essentially, what I'm kind of highlighting with these languages is you can use a series of different languages to develop in a front-end framework, in a front-end ecosystem. All of them will end up kind of being JavaScript at a lower layer because that's what's supported on a front-end environment in a browser. So going from the least well-known to the most well-known, and I think a lot of these languages are clearly much better, they perform better, but they do pose their own kind of challenges associated, maybe with like extra learning hurdles and stuff like that. I would say if you're going to choose a language, a lot of these performance things are great, but personally, I found in a front-end space, a lot of front-end performance issues are more related to bad coding and like poor image optimization and stuff like that, which is maybe harder to do with these functional-based languages. Right? And I think one of the big perks to Reason, which Jason didn't mention right now, is that you have no runtime errors, which is a huge kind of improvement on debugging your code. Anyway, let's go through. I'll go through it quickly.
Maybe just to clarify, you
Sure.
have you basically push your runtime errors out. So in your Reason code, as long as your sort of interfaces with JavaScript are correct, there won't be runtime errors. But of course, the JavaScript that you interface with can have runtime errors. And let's say I want to call a JavaScript function that takes 5 arguments, and I tell Reason this function takes 4 arguments. There will be an error. So as long as you make correct assumptions at the beginning, you push all of the errors out of your code, if that makes sense. So if the core of your code is written in Reason, it's easier to find where those errors are. And when you refactor your code, as long as your original assumptions were correct, it's unlikely you'll introduce new runtime errors. So yeah, just a clarification.
Cool. ClojureScript is another functional language. It compiles to JavaScript and is based on a syntax like Lisp, as a dialect of Lisp. Then Elm is loosely typed or inferred typed. Functional, again, you can see there's consistency with people wanting functional-based languages. Also boasts no runtime exceptions, good timing on that to pop up. And it has a syntax similar to Haskell as well. Then Coffeescript was a mention that I thought was worth noting as well. The syntax is based loosely on Ruby as well as Haskell. And you can see here's kind of the difference in syntax. I think it's also loosely typed, so you don't declare what type it is. And cool. Then the crowd favorite, not that it's the best, is TypeScript. And TypeScript essentially solves one core issue with JavaScript, that it's untyped. So as simple as it says, it's TypeScript, it's typed JavaScript essentially. Interesting enough, maintained by Microsoft, which, interesting enough, Sean mentioned earlier, was kind of the spearhead of the JavaScript language. Okay, cool. So those are to cover some of the languages. At the end of the day, you can also use JavaScript. These are just to kind of highlight some of the benefits in building a different kind of system. And they can be quite interesting and change paradigms to program in these languages. But again, they kind of map down into JavaScript at the underlying base layer. Okay, now I'd like to chat about some of the front end.
Maybe could I say a few things?
Sure. Go for it. Try keep it quick though, because I do have to go through, but go for it.
When I guess looking through these languages, there's different sort of trade-offs that are made. Some are like the speed of the compiler. For example, Elm definitely does have stronger no runtime exception guarantees than Reason, but it's way more difficult to do anything with JavaScript. It's crazy. You have to use ports, and yeah, they basically, the people who use Elm think JavaScript is evil and you should never touch it, whereas the Reason people are like, let's make some compromises. And some of them are much more similar to JavaScript. So I think the success of TypeScript is that it's a superset of JavaScript. So in theory, all JavaScript is TypeScript. None of the other languages listed there are the same as that. And I think that single fact probably was the biggest reason for success of TypeScript. Yeah, that's it.
Cool. Then we come to the more well-known actual front-end frameworks that are kind of built on top of JavaScript. And these are usually, so to give you some historical background, the vanilla JavaScript is kind of the original, that goes back. And then there was quite a popular framework called jQuery, which has slowly been getting less and less popularity. And so that was kind of the single predecessor to these frameworks. And what, as computation on people's computers became stronger, people started doing more complex computations on the front end. And I think this is where these kind of come out of. So I'm going to fly through these first three. I'm not too familiar with them myself, to be honest, but Ember.js, Svelte, and Preact. These are three others notable mentions that I'm just going to mention briefly with different kind of arguments. I think the notable difference between Svelte doesn't have a virtual DOM, and then Preact is similar to React. Well, in fact, it's the same syntax as React, but it's a lighter package. And I Googled some of the reasons why you would use React instead of Preact, and it's mostly it'll be fine, but there are one or two kind of compatibility issues you may run into doing certain things, but it's considerably smaller than the current React. And this is actually a framework that's gaining in popularity. Okay, and then we come to the three titans of the industry: Angular, Vue, and React. And these are ordered in order of most popular, or most liked, or market adoption. So to briefly brush up on the three, there's Angular, there's Vue, and there's React. Angular is maintained by Google. Vue was originally developed by a single guy, Evan You, and it's got some diehard fandom. And then React is maintained by Facebook. They all kind of do a similar type of functionality, or they offer a similar kind of offering, and that is it allows you to much more cleanly kind of asynchronously update the browser. So you're not like fetching a new file every time you visit a new page, or you're allowed, essentially allows you to take a component such as this section here, and if you're going to change it, it only changes that portion of the website. I think that's kind of the very entry-level kind of explanation of what these problems these frameworks solve, and they are extremely quickly. They do it extremely quickly. From my personal experience, I've worked in an Angular and React environment, and I'd say Angular is particularly is good, but I'd say I just prefer React. And interestingly, React has a market adoption of about, I think last time I looked it was 78%. So they're just generally more popular as a choice. And then I spoke to someone from a company I can't say. They're the head of, well, I don't want to say if he's streaming, but they're the head of tech of a company that just raised $46 million or so. I'm trying to convert it to dollars, not from rands. And they use Angular on their stack, and the head of tech was exploring React and kind of thought it was a nicer to work in framework. Not that they both don't serve a purpose and can both kind of solve the same broader problems. Then Vue is a notable mention. It was initially developed by one guy, Evan New, and it seems to be very popular. I haven't coded in it too much, but I have explored it lightly. And then the monolith React, which is maybe I'm not sure if it was the first. Does anyone know which came first, React or Angular?
I think Angular came first, but Angular was, very similar time, but definitely first. But React, I think, really succeeded because of its components. Angular before, it was like you're buying, I actually don't really know Angular too well, but Angular 1 I did use, and you basically like have your normal HTML kind of page, and then you have these like bindings. I'm trying to remember what they were called, like the ng, you tag them with ng. Yeah. And then those like things you can update from like other JavaScript. Whereas React, it's very, very nice. You can have literally components that it's like building with Lego. You have like this component, you put it here, and they kind of separate, and that's easier to think about.
Yeah, cool. So those are some of the kind of JavaScript built on top of frameworks. And now I'd like to delve into some kind of notable mentions of some server-side frameworks. I'm just going to brush on them briefly. I'm not too familiar with them apart from Express and ASP.NET. But these are essentially frameworks that allow you to develop on a server-side, in a server-side environment, and it pushes the content through to the front end. So you have Phoenix framework, which is an Elixir-based framework. You have Ruby on Rails, which is based on Ruby. You've got GenWeb framework, which is on top of Golang. And there's a whole bunch more than the ones that I'm showing you. I'm just showing you a few different flavors from different kind of programming languages. The one that people are generally more familiar with is Express in a Node.js environment. And then you have ASP.NET Server and ASP.NET Core, which is Microsoft's kind of server-side rendering website framework. So I'm not going to delve into these too much. There's definitely more, but I'm also kind of wanting to emphasize that you don't have to build everything in a JavaScript on the front end space. And they generally follow kind of a model view controller type layout. Okay, so these are some of the honorable mentions, some of the frameworks that are maybe not so categorized into what I've covered already, which I think are quite interesting. So SEO friendly, that's the big thing to note here. So there's obviously benefits of having your websites kind of manage everything in the front end, but there's also huge shortcomings. So a big example of this is you can't control how someone's laptops or computers performance. So they might struggle to handle a website where you've got some probably buggy, heavy computations on. But if you have it on a server, you can kind of juice it up as much as you want. You can implement request caching. You can do some optimization things. And notably, one of the biggest issues, so React and all these frameworks, they're built on top of JavaScript, which makes them super, super great for any type of application. And when I say application, anything that sits behind an authentication wall or a login wall, because it's built on top of JavaScript, Google and other search rank engines can't read JavaScript. Okay, so Google has, when they rank different websites, they have these things called bots or robots or crawlers, and they go through the internet and they visit every single website. And while they're visiting a website, they read the data from the website, and then they cache that and have their ranking algorithm. Now, if your website's built in JavaScript, which, for example, React is, you'll come across the issue that it'll say, if you don't have JavaScript enabled on your browser, for example, I can't think of a website right now, so I won't show. But if you don't have JavaScript enabled on your browser and you try to visit a React-based site, it's just going to say you need to enable JavaScript, which is exact same thing that Google's crawlers see. They just see a piece of text that says you need to enable JavaScript, which means it's extremely hard to rank in Google, which means your search engine optimization, your SEO, is kind of pointless in these frameworks. But fortunately, there are solvable problems to this, and that would be kind of a mixture of server-side rendering these front-end frameworks, as well as generating them into static content. So Next.js is a React framework that allows you to server-side render your React. So instead of the JavaScript operations running on the user's browser, it runs on the server, and it's read, and then it's pushed to the front end. Now, that's the one aspect of it. And then the other side of it is they also, so that's server-side rendering, and then they also push it into static files. So those are purely static files you can put in your front end on just a file server, and you can read that as well. And this allows browsers like search engines to rank your site, because they can read the content, because all they see is the HTML and CSS. They don't actually see it doesn't require the JavaScript computation. The notable one for server-side rendering in the React environments is Next.js. I'm just going to move this one here. The one in Vue environment is Nuxt.js, and I've got a video here which explains things quite well. It's very similar to Next.js in kind of what it solves. Then there's Gatsby, which is a React-based framework, usually used for systems like blogging and stuff, and it's quite useful for backwards compatibility with existing operation backends for like WordPress. If you have a blogging system where you use WordPress to save your blog and stuff, it plugs in quite well with GraphQL, and that it doesn't server-side render it, but it generates it into static files, and it uses GraphQL to make the requests to pull that data from your different data sources. It's a great framework. I do find that I prefer to work in a Next.js environment than a Gatsby environment, and just because Next.js feels a lot like just vanilla React with a few differences, whereas Gatsby kind of, it feels like its own flavor, and you've got to create plugins for certain functionality that you want, etc., etc. Angular does have a an option for server-side rendering as well. So these other ones are Electron, React Native, and Ionic is what's going to wrap us up. Electron is, so what's quite appealing of using kind of this framework for a web environment is it's quite easy to port your applications into either a mobile app, so like an app on your iPhone, or a normal desktop app. And this is done with some pretty simple, clever mechanisms. But so Electron is a framework that's built on top of Chromium, which is Google's open source browser, which essentially runs, it allows you to create a desktop application from any website. So you can, and it has some clever things that kind of run with your internal system. So you can, so for example, I think Spotify is built on top of Electron and Chromium. It's just a web browser portal that's in its own app. There's quite a few. In fact, I think, Jason, maybe you can correct me if I'm wrong, or VS Code, or used to be at least.
Yeah, no, VS Code and Atom are both. I think Atom was the first one, and they built Electron and Atom at the same time.
Okay, so essentially, it's just a Chrome browser that wraps it runs your JavaScript or web code languages into a desktop app. Super useful. It makes code very maintainable. And then you come to the other end of the spectrum, and that's allowing you to develop mobile apps into, so like an iPhone or Android app. And there's a few different kind of frameworks that allow you to do this, but some of them are essentially browser based. So similar to Electron, it kind of just runs its own browser and it's still kind of a web app. And then you get some performance improvements when you run native apps, which essentially they transpile into native Swift code so that it can run with the same. So you're just using a kind of a React environment, but it gets coded down into that unique device's kind of native language, which makes it super practical, or you get kind of speed improvements and stuff. And the notable one being React Native. And React Native is trying to promote itself, I'm not sure here if it is, but as more than just a mobile app kind of environment, because their argument is if you can develop a React Native app, why not develop that into a website as well? So you have a single code base that's acting as a mobile app, and it's acting as a website as well. And it would be even more exciting, and you can definitely do it to develop that into an Electron app with a little bit of kind of fluff around it and exceptions and stuff. But essentially, you can have a single code base that develops a website, a mobile website, a desktop application and the beauty of Electron is it runs on Ubuntu, Linux, Microsoft, and Apple. You don't have to worry about which platform. I mean, there's some performance costs, but I think if you're not doing something too computationally complex, you really benefit from having a single code base that's kind of very compatible with different devices. And so React Native is kind of promoting that you have a single code base for all these different applications. So you can have an Android app, you can have an Apple app, you can have it's really quite forward. I mean, it's really easy to maintain, and it's great in terms of kind of adoption and allowing you to develop once across so many different environments. And then I thought I'd mention Ionic, which is something I worked in before. So historically, Ionic used to be they're not directly affiliated with Angular, but they used to be an Angular framework, and it allows you to develop mobile apps as well in a JavaScript environment. They have more recently, and probably for more than a year now, I think, included React, so you can code in both React and Angular to develop an Ionic app. Ionic is a web browser-based thing. So it actually just creates a browser as an app and runs your JavaScript, which means it has slightly slower performance than React Native, but it has a lot of very developer-friendly stuff going on, and it's really, really easy to develop a kind of a proof of concept in Ionic, because you can get something up and running that's looking very like advanced in a matter of like in an hour. You could have a kind of a basic app, and it's really quite quick to develop in Ionic. It's very developer-friendly, should I say. So I think that covers all of the different things in a front-end environment. It's by no means exhaustive, but I just thought it would be some of these kind of frameworks and stuff just to give a better understanding.
What do you think of this comment, Denim?
One thing that I personally hate more than JavaScript is CSS. Yeah, so it's quite well known that CSS is the most hated language on the internet, and I must say it's a nightmare to get right. When you do start getting things and you kind of get familiar with it, I'd say you start enjoying it a little bit more. But it is a pain in the butt. It's extremely difficult to and unintuitive of like certain design. Like for example, if you're trying to vertically align stuff, it's very difficult. But with CSS3, I'm not sure if I must have been CSS3, but Flexbox is a kind of, because what's been so difficult with CSS is actually just positioning things. The actual styling stuff is kind of all right, but it's the positioning of elements on a page and making that position with different screen sizes. But Flexbox really, 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 if you can understand Flexbox, which is not too complicated, it really makes a huge difference in designing responsive layouts. Yeah, but it's a very well-hated language. Cool. I think that covers.
Thank you. Yeah.
There's maybe a few things maybe I could add. I think your explanation of Next.js was great, but I think maybe one thing just to clarify if people didn't fully get it, the code is server-side rendered. So as your website lands on a Next.js website, it's the same for Nuxt and a lot of those other platforms. As it lands, it loads HTML and CSS. That's the first thing it lands. So first thing it loads, sorry. So the experience for the user is quite nice because everything pops up really fast and it looks good. And then there's a process afterwards called hydration, where it actually loads the JavaScript in the background. So the feeling of the app after it's loaded is the same. It's not like a PHP website where every time you go to a new page, it has to like reload the whole page. So yeah, I thought that was maybe something to clear up.
Cool. Cool. Thanks, guys.
Sharing next Friday. What do we have?
Marvin.
Yeah, sure. Happy to do something for next week. I'm not entirely sure what's going to be. If you want me to do it, I will need maybe some.
You mentioned like a continuous delivery, CI, continuous integration, DevOps.
Yeah, sure. I can do like an overview of the tools and techniques that we have there. What the hardest stuff right now is on how to put stuff into continuous integration delivery. Sure.
Yeah. But you don't have to design.
No pressure, but yeah.
And anyone listening, if they have something really cool, you can message us. So anyone from the community, yeah, we'd be happy to have someone else share.
Yeah, I should have given Ben a chance to punt his Elixir Phoenix framework. I'm sure you would have.
Yes, Ben, I think you are watching. You were watching.
Yeah.
People's your idea is interesting, so it's great.
Perfect. So that's going to be next week.
The thousands
cool,
of
guys. Yeah.
Awesome.
Chat soon. Ciao.
Cool, guys. Bye.
Enjoy the
Have
weekend.
a nice weekend, everyone.
Yeah.